All right, we are live. Hello, hello. This is day 13, I think, of studying compilers until I land a compiler role. Yeah, I guess same as usual. We're just gonna keep going on the leetcode daily. Figure out differences between the file input stuff that I was working on and like the REPL for the kaleidoscope compiler, and then we're just gonna keep chugging with the tutorial. Yeah, surely I have time for that, but we'll see what happens. As expected. Since yesterday was minimum error to cover all ones 1, it makes sense today was cover all ones 2. 3 non-overlapping rectangles. Having non-zero areas. Okay, this might be a little bit doomed. Minimum possible sum. I have no idea how to even begin approaching this one. Two rectangles, sure. Yeah, okay. I don't think this is worth thinking about for too long, so we're just gonna go straight to the editorial. I guess this makes sense. Sure. This looks very comprehensive. Okay. Yeah, we're quite struggling here. UDLR. Okay, I guess that makes sense. Rotate is a thing? Oh, we create rotate. Okay. Okay, well, I guess that makes sense. So okay, so we steal a minimum sum from last time. And then rotate is rotate. Solve. I guess this makes sense. This feels really slow. I guess this problem is inherently really slow, so fair enough. Okay, well, I'm just gonna copy the solution from yesterday to begin with. I think that's a good place to start. Okay. Oh, it's here. So you have that, and then okay, let's go back here. Okay. So we make the first split, and then we make the second split. Okay. The solution feels really slow, though. At least. So what else? Ah, the other difference is we can't really... Actually, no, this is fine, because this doesn't make changes to grid. So, okay. Okay, so then int solve. You pass in an int 2D vector. So then rows is size, and then columns is grid 0 dot size. Let's change that. What is happening here? Okay, so that is one rectangle. Oh, okay. So this is one split, and then this is the other split, and then this deals with the... Okay, I see. That makes sense. So we have... So we can handle 1 and 2 in the same loop, and then 3 we handle separately. And then 4, 5, 6 we just rotate and then do it again, it seems like. Yeah, this is definitely a problem. And then we need to pass in other things. So u, int l, int d, int r. This was the worst possible order I could have done this. Let's just move that here and call it a day. Let's put this. So 0 is 0 would be u. And then this would be d. And this would be LR, presumably. So then in here so then I is the split. So, okay. This is res. And then this needs to be, gotcha, areas, okay. Then we need to, what do we sum here? Then we pass in, what's this called? Minimum area. What do we give this? Let's open up GIMP so I can draw things. Okay. Oh, it's blue. Oh. There we go. So that. So this is I. We'll just mark this as J. 0, 0. That's J up here. And this is C and this is R. So we need this split to be at least 2, right? Because these need to be non-zero. So I is the possible splits one way, and then we can figure out the J split after. Or I guess I have the same criteria, so minimum is 1. Okay. It might be easiest to think of this as the far bound, right? Yeah, the far bound. So we'd want this to be 2 less than equal to R. And then same for J. So we want to pass in 0, up, down would be controlled by I. So 0, I, oh, we need to pass in grid. So grid 0, I, and then let's pass in 0, and then let's pass in C for now. What else do we give this? Minimum area of grid. So now we do from I to R. And we go 0 to J. And then we can just copy this. And then instead of 0 to J, we do J to C. And then we do this again. Can we do less than or equal to R? Because that leads to a 0 rectangle, right? Because the bound would be the end bound. Yeah. So we'd need to we'd actually just get rid of the equals here. And then here, this one we go from so this one, instead of these two, so here we put the 0 to J. Actually, we can just swap these in here. I think. Yeah, okay. And then here we throw in another loop. Probably reuse this one even. Yeah, and here. And J equals I, J is less than. No, it has to be I plus 1. Because we need the whole non-zero rectangles thing again. And then this condition here, J is also less than C, I guess. Yeah. And then we just skip the last iteration of this. Oh, wait, no, not C. We want R again. R minus 1. Then we continue. Actually, we just break even. And here we return res. And then we steal this again. But instead of this, we go 0 to I, and then I to J, and then we go J to R. And this is 0 to C each time. Sun beat C9, 13-11, let's go. Good outcome. This should be good, so then... Okay, now we get to rotate this now. Rotate, vector, int. Oh, 1310. Okay, even better. Grid 0 dot size. Grid dot C equals grid dot size. So when we make a new vector and return it, so this has size R and then vector int. That's C. We don't even need to rotate this properly because area is area. So we can just invert it even. Oh, this looks quite diabolical, I will say. Res of J of I equals grid of I of J. So we return min of solve grid and then solve of rotate grid. I'm gonna have forgotten a semicolon somewhere. Oh, it's an oh no. Okay. All right, let's make a temporary. And then we put this in here. And then this should work. Nope, it doesn't. Okay. Let's see, where is this going wrong? well, let's do a little bit of comparison. Ah, that's how we did it. Ah, but this is wrong. I see. There we go. Alright, well, it's slow, but, I mean, sure. What do the fast people do? They just skipped the... Okay, sure. Yeah, okay, great. Okay, well, that's enough of this. I can't say that was a fun problem, but especially after having done an OA earlier today. So, glad to see that's done. So, let's close out of this. Kaleidoscope. Yeah, that size seems fine. So last time we got through the JIT portion of the tutorial, so I'll just move this here. Yeah, so we got through section. This is the wrong section. 04. We got through this, the JIT compiler. And then I think all of this works at least. So let's just give it a try. So yeah, let's run with this. So you pass in sine x, pass in cosine x, and then sine of 1.0 gets evaluated. And we can define a function that uses those. So def foo x is sine of x times sine x plus cosine x times cosine x. Yeah. So then that writes the function, and then we can call it with like this, and then it evaluates. And then in a previous implementation, after it evaluated, it would drop the environment. So after changing that, we should be able to run it again. Yeah, okay. So that works now. The thing I haven't checked though was if this still works with the file input sort of stuff that I messed around with before part 4 of the tutorial, which is this. So the tutorial was this run interactive stuff, but I worked on reading file input and making it print things. So I think the intended behavior here is to not include the JIT with this, but just to run the optimizer on it and output LVM bitcode currently. So I guess we'll give it a try here. I wish I had your determination at your age. I love compilers. Thank you. That means a lot to me. Compilers are definitely part of the reason I'm actually like this willing to stream, because I just think they're really cool and I want to learn more about them. I don't think I would be doing this if my interests were not particularly CS geared. It just feels like it just felt like there were very few resources for beginners to get started, so it felt like it made sense for me to at least show some portion of my learning journey. I don't want to run it like this. I want to pass in tests. Let's pass it test.in. Okay. So it doesn't work. And why is that? I know why. It's because non-the-lexer. Yeah, here we are. Anon expert. This is different. This is different behavior. So then this stuff should still work barring that at least. It's just everything will be vomited out in its own module, it looks like. So then where does this happen? There it happens. So then let's just check if the JIT exists. So if the JIT exists, then we can what's the best way to do this? Can we just do a ternary operator? So std string name equals so if JIT exists, then anon expr, else it's just empty string. Then we change this to name. And this shouldn't cause any problems. Although if it does, it'll be really funny, so. Okay, so then LVM dis kaleidoscope. Let's look at this. Okay, it looks like it all exists. I think this test file included everything I needed at least. I can make a bigger test. We don't have user-defined variables yet, so that will be a future thing to work on. And by future thing, probably, I think that's in 2 chapters. Yeah. So, 3 chapters. Mutable variables is 7. Before that, we have user-defined operators and control flow. Given that there's actually not that much that was broken, I think I should be able to get started on control flow. So that'll be a good time. Yeah, so what's that? There's this. Let's see, what else can we optimize? Or what would be an optimizable function here? So we have this mess. It seems pretty comprehensive already. Let's give this. What do you do with this? Let's give it. Struggling to think of anything interesting. Okay, let's give it. Actually, I think there are some examples in this that gave things that it didn't quite do yet. I guess not. Okay, well. Wonder if this does anything. So let's clean this up. And then let's run this with test full. Am I missing something? Oh, this is parsed differently. Yeah, maybe there's a. Maybe I should be calling this on everything at once. So this would, I guess, also be in parser for better or for worse. Actually, no. Would it be? And then let's just clean format real quick. In place. On. Oh, okay. I guess that formatted JIT as well. Fair enough. Let's see. What else do we want to do here? It's probably in compiler. And how do we run this again in parser? Let's make this a little bit more me-sized. So wherever the validator lives. AST? Oh, it's in cogen, yeah. It has to be in cogen. Yeah, verify. There we go. So we can do this, and then have the module manager that we can run as well, right? So we could probably put this in here. Let's get rid of that. Then we put this here. So then npm, do I have a module class manager? That would be an LVM. Module analysis manager, okay. Or wait, no, wait. LVM pass manager. How do we use this? Oh, that's nice. That's very helpful. That's really funny, actually. Okay. So then... Then does this add the module by default? How's the journey going? It's definitely going. Whether it's smooth is open to interpretation, I suppose. I've definitely learned more in 2 weeks than I have in some quarters at school, so I'd say that's pretty good. Thank you, I appreciate the support. Looking opt. Module analysis manager. Okay. So we should be able to just run that at least. Run. Oh, wait, I need to build the module pass manager. Let's do it in here, which is, I forgot to add it to Harpoon, unlucky. So let's make another thing that we export from here. So then, void run passes. Run module pass. And then do we need to give it the thing? I don't think we need to. No, we don't need to, because these are already globaled. Module pass manager npm equals. Do we have a pass builder that's globaled? No, we don't. We should probably global this at least, I think. But then initialize always overwrites it, I guess. Do I need a unique pointer? Yes, I should. LVM passbuilder. And then 29. Ah, we can do a little thing here. PB. We can. There's a way to reset the pointer. I forgot how. Unique pointer. Yeah, okay, this makes sense. Yeah, that's okay. That's what I was looking for. Reset. So PB reset. We give it new LVM pass builder. Oh, dot reset. Oh, that's a lot of that's a lot of autocomplete. So I don't think PB is used anywhere else, so we should be able to just use it here. PB build. Ugh. Give it LVM optimization level. Let's go with 2. I think that's all this needs, right? It's not yelling at me, so. Yeah, so then we can just call run module passes in theory. Run module passes. I think I have all the headers already, so I should be fine shortly. Oh yeah, I guess that requires a lot to be rebuilt, just for dependency reasons. The Lexer is always good. Okay, well I guess that didn't change anything because we were already running optimizations every time, but it's per function, right? LVM module passes. There's so much stuff. I don't even know how to begin to look at all of this, but let's see. How can we verify that this is running? I guess we could get rid of this, or we could run this only if digit is active. There we go. Okay. Let's just make clean while we're at it. Okay, so then this, and then we can look at this file. Yeah, it looks about the same. Shocker. You study with docs only, or sometimes you watch videos / tutorials as well? I've mostly been docs land just because I feel like there's not that many video resources, at least at a more granular level. If there were video tutorials of that caliber, I would probably follow them, but for now it's just been docs and books. Or at least an attempt at books. And just to test that this is working, let's see. You can comment this out. Let's rebuild that. And then if we run it again, still runs? Huh. Ah, this is the one that we wanted to use as an example. So let's add that to the full test. Test again, x 1 plus 2 plus x times x plus 1. That's a great way. We don't have things in depth in videos, but would recommend Pixeled series on building a compiler. I think I've glanced at it. Yeah. Oh, there's actually quite a lot. Yeah, I think I'll take a look at this more comprehensively in my free time. that is a good resource that I forgot about. Thank you for bringing it to my attention. And yeah, there we go. So then if we run module passes and then rebuild, and that should collapse, surely. Kaleidoscope tests full. And this. Okay, well I guess this might just be a little bit doomed regardless. Being a JSTS developer, I wrote a compiler one day, definitely not the same, but more. I think that's fair. It is definitely really important to just understand tooling. Good luck, man. Thank you. We need CSE and reassociation. Do we have those? So we do have those passes. Aren't they running? So I have the function pass manager. These are analysis passes, so do we need to register those? Congrats for a step and good luck on your journey. Thank you. It means a lot. Where's the big reference again? Yeah, okay. So it was built. So why is it not running? Oh, I know why it's not running. So we've made the manager. Now we need to npm.run. Whoops. And then we need mam. That module. Oh, we need to dereference. That's why. That's not supposed to segfault. Why is it segfaulting? What do you do currently? I go to school. But I'm currently still on summer break, so I've got like a month until a little under a month until classes start back up. the seg faulting? Oh, I need to. I think I need to like do something with the pointer. Do you do stuff like this in university? I don't really, or I haven't really gotten too into the weeds with it yet. I do like some compiler research, but I don't. I haven't really worked with LLVM proper, which is, I guess, part of why I'm working on this right now. Why doesn't this? This has. Why is this seg faulting? Just run it through Valgrind. Okay. Well, that doesn't help me. Then snap. That doesn't help me. I guess I should have expected about as much, to be honest. Why is this? Let's give this to ChatGPT. I don't really think I would, even stepping through this with GDB would be helpful, given my knowledge. Oh, right, I don't have scrolling enabled. Oh. Wait. This isn't too much, that's why. That. Okay, well, I guess that makes sense. So then we need this, and then we need that. Okay. CG, UGM. Function analyses, and then we need loop analyses. let's try making now. And maybe this works. I don't really know what's going on with the pass manager. If anyone in chat can give some semblance of an explanation, that'd be really neat. This looks like this ran. Uh-oh. Oh, wait. And, oh! Okay, it does things. Interesting. Okay, so it ran with oct. That's really neat. What else do I need to test again? I need to make sure this isn't being run in the REPL, because then that would be deleting various pieces of dead code, I think. Okay, looks good to me. And then, yeah, okay, that's like, sure. Wait. Oh, I see. Okay, well, guess that makes sense. Is it supposed to vomit out stuff after, based on the implementation in here? Unspecified. Okay. Oh, right, because it does, it has a, because we split it up into new modules after every call, I think. Yeah, that explains why it's an empty module. That makes sense. So def foo x1, and then this should print out something. Huh. Okay. Well, let's see how they print after. Do they even print after anymore? It's the main loop. It's down here. They don't. I've been scammed. In hindsight, that makes complete sense. Yeah, because we don't really need to print anything anymore because it's being jitted. I've just made that a new word, I guess. So we'll keep dumpire as a thing in the event that we need to, well, print the module, but it won't be called in the main loop anymore, I suppose. So then we can go here, we can take this stuff out now. Yeah, that's good. And then we can take this out. Let's do a clean build, actually. The reason for that, I wanted to. There's no logical reason for it. Actually, there is a reason. Just making sure that everything completely works from scratch after all of the changes are, I guess, put together. So let's run this. So we def foo x as x plus 1. Okay. That's not supposed to happen. Var x foo x plus 5, I guess. I don't know. Okay, I might have to see what's going wrong here, but let's do bar of 10. And okay. So what's happening there? Let's be in parser. This would be after tokdef. Right? Yeah, or no, wait. Yeah, it'd be after tokdef. Does this happen with externs? It does not. It does. Interesting. Doesn't happen with default. What happens if I just stick an fprintf here at the top? Or even just a new line? Oh, wait, I think I know what's happening. It's reading this semicolon, that's why. So let's delete this. Let's put it in here. Let's also put it in here. It should go before the break. Let's put it here. Let's rebuild this. Hey Nitro, how's it going? Okay, it looks like this has fixed the thing. Okay, neat. The only other thing I want to change here is in the main loop. On graceful exit, we want it to new line. as it goes. So I think with that, then that resolves pretty much all of the small annoyances I've been dealing with. Built kaleidoscope. Let's just skip some steps. Okay, there we go. Let's add everything. Let's diff parser. I made other changes, right? Yeah, okay, I did. Add file input, optimization, opt support, and what else did I do? I fix main loop printing, interactive printing. Okay, so that's that. I learned something cool about C++ compilers today. Using lambdas to call a function instead of using a function pointer has much better performance because it allows the compiler to inline the code. That makes sense, yeah. I don't know a whole lot about how lambdas are generated, but I wouldn't be surprised if, I guess they're just literally given an inline directive. That's really cool. Thank you for sharing. Okay, so I think that's all of chapter 4 done in record-breaking time of a week. Incredible. So yeah, now we get to extend the language with control flow. So that'll be a good time. Welcome to chapter 5. Thank you, LVM book. Unfortunately, as presented, kaleidoscope is mostly useless. There's no control flow other than call and return. You have conditional branches. Yeah, that's fair. This is quite important. Extending to support if then else is quite straightforward. So we just need to add this to everything. That makes sense. So we have if then else syntax, which makes sense. Seems fair enough. So everything is an expression, so then if then else needs to return a value. Since we're using a mostly functional form, we'll have it evaluates conditional, then return then or else. Okay. Okay, so it's just a functional if else. I guess functional if statement, just straight up. And 0 is false, everything else is true. Okay. Yeah, this seems very PLE, which makes me quite happy. Okay, so it all starts with a lexer. We want to add new values. Control flow. So if we'll just keep tacking things on here. So we have that, and then we need to throw it in here, presumably. If identifier indent, great. Identifier string if return toke if let's run clean format on that. Okay. Yo, what's good, Rudy? That reminds me, I think you asked the question last time at the end that I didn't catch. It was either you or it was someone else. Making good progress? Not really. I kind of just have to wait at the stuff I had again. But I guess now we're moving on in the tutorial. Okay, so we've added this in the Elixir, so now we need to add in the parser. Oh, we need to add it in the AST, I think. We need to parse. Then let's put it in here. So in the main loop, we need an if token. Yeah, okay, we just stuff this in directly, I guess. Wait, no, we have a separate parse function. Oh, and it's a primary expression. Okay, I got that wrong. Okay. So let's start with parse if expression. I guess we need to put this somewhere here. I guess since it's a header, it doesn't really matter where we're putting this, but I think it's cleanest if I put it here. Unique footer to expr ast. Actually, no, this goes up here. Parse if expr. Hi, I'm a compiler. That's good. Mouse and red car. So this goes after identifier expr. Goes after this. So it goes on a parser, and then okay, so we get next token, which eats the if, and then autocond equals parse, yeah, parse expression. This is all pretty boilerplate. If it doesn't exist, then we return null pointer. So that's done, so then we get next token, I think. No, we check that it's not a then. Okay. If token. Oh, we have to check that it is a then. Kurtok is a field. Yeah, that makes sense. And this is lowercase. So then So now we're on the then statement, so then copy this, I guess. And we replace cond with then. And we return no pointer. And then we copy this again. And then we replace this with else. And now it's annoying because I think else is a reserved. Is else a reserved keyword? Let's give it a try. Yeah, okay. Otherwise, nah, let's true branch, false branch. False branch doesn't exist, then return null pointer, and then we make the if expr. Oh yeah, I need to make the node real quick. Then harpoon. Let's make the node. I think we need to make it here as well. Put this here. So then class if expr ast extends public expr ast. So then this has a constructor. It has unique pointers to expressions in them. Cond T branch, and then false branch. Is that all it needs? Yeah. And then let's put this down here. We need the private fields. I guess this is a little bit trivial as well. What you making? I'm following LLVM's my first compiler front end tutorial. So this is the intent of this is to be a compiler for this language that they have called Kaleidoscope. So this is like an example program. It's pretty minimal, but its intent is to, I guess, get me familiar with the LLVM ecosystem. Yeah, I think that's all the header needs. Then let's steal this for now. Oh, this is gonna be a mess to figure out where it lives. After call expr, this is where I'm putting it. To be here. Alright, man, keep up with the good work. I got a bounce, but crazy inspiring to see you're still committed. We'll try screaming a Game Boy emulator project within the next week or so. Looking forward to it. Let me know how it goes. Where's my mouse? There's my mouse. What am I missing? Oh, I need to stood move. Actually, let's surround word with parentheses. Wait. Surround word with brackets. And let's add stood move. Surround stood move. Format. Okay. That looks good. So then we can go back here and we can create the AST node. So we return stood, we make unique of type if x per AST with cond move T branch and then move F branch. Okay. So now this if statement should be a primary expression. So let's go down here. And we add case toke if return parse if expr. So that should be it in terms of parsing it. So now we actually have to generate the code. Because currently we've just linked it in the parser, but we still have to implement this. Where did I put this? In the AST. This overridden LLVM value cogen. Oh boy. It's gonna be fun. So let's do value if x per AST cogen. Just vibe code, it's okay. I could, but I also want to learn. And like, if I were to vibe code, I may as well just copy paste straight from the tutorial. So I'm gonna keep some of the pedagogical value. It's true, the code is literally in front of me. Yeah. So let's take a look at this example. Oh, wait. Okay, I should read this. This is where we introduce new concepts. Are we adding more basic blocks? Is that what's happening? Foo bar. So we define that. These exist, then. Okay. Oh, this is a thing? Oh, view CFG. Okay, I see. One. Interesting. I guess that makes sense. Ah, and then there's a fee. Okay. Which book to prefer to become a compiler developer? I'm not sure either is the thing. I'm still trying to find good reading resources, but the two that I've been pointed to the most are the Dragon book, which or I guess like it's called Compilers, Principles, Techniques, and Tools. And everyone calls it the Dragon book because, well, it has a dragon on it. And there's like either the second edition or the updated second edition is the one. And then the other one was Advanced Compiler Design and Implementation. This one here. And I think this one gets more into the middle end. So I think those would be the ones to look at. I've been starting to work through this one, at least in my free time, because I tried reading through the Dragon book and it was low-key too dense for me. So yeah, I'll give you a report on that. Ask me again in like 2 weeks. What is a basic block? I remember it being related to something in IR. Yeah, so I think I can kind of actually explain this. So when generating the control flow graph, sort of like in this image here, so like the naive approach would just be to have each instruction as a node in the graph, and then that has its like predecessors. But the problem with that approach is that it's there's a lot of like straight line connections, and that is a little bit I guess it adds a lot of complexity with not really a lot of benefit, because you'll just be traversing through it anyway. So the idea is to take all of these straight line instruction sequences, so like these two instructions here in the entry, for instance, or I guess all these are two instructions, but just any of these sequences of two instructions. And since there's no way their execution order can change, the idea is to just group them all into one node. And that node that contains these straight line instruction sequences, that node is called a basic block. So entry is a basic block, then is a basic block, else is a basic block, and then if const is a basic block here. Okay, view CFG, sure. It's really neat. Entry block evaluates the conditional here, compares it to 0. Wait, soon get, okay, that makes sense. LVM has many nice features. So the entry block evaluates the conditional. I guess that makes sense. That's the comp. And then based on that, it branches to then or else. And then they go back. Okay, fee operations. This is like the part I actually need to read through. Okay. So as a refresher, SSA is static single assignment. The idea is, yeah, I think this is a sufficiently good explanation, but the idea is that when you're reassigning variables, there's a question of like which of these assignments dominates the other. So I guess like in this assigning x to y operation here, we don't know what y is, or it's a little bit annoying to figure out what y is. So the idea is just to make each assignment a new variable pretty much, and that makes it really easy to tell which of these is used in this assignment. So going back to this, the problem here that we're trying to solve with the fee is that these two call temps are different, and we don't know which one to use. So the fee is sort of like the join for those, I guess. I might be incorrect around the edges with the semantics. If anyone knows of any part where I'm like really butchering it, please let me know in the chat. Execution of the the operation requires remembering which block control came from. Takes on the value corresponding to the input block. Okay. So if it comes in from then it gets call temp. If it comes in from else, it gets call temp 1. That makes sense. Oh no, this means my simple and elegant front end will have to start generating SSA form. Were all of them related to the LVM tutorial? Most of them have been. The first couple of them were me working on a personal compiler, which I think will be the next thing I work on after I get through this tutorial. But I fear it might be a hot second until then. So there's also one stream where I just messed around with like Clang format. Okay. So we shouldn't implement SSA construction. Code that involves user variables and then implicit values. Okay. I guess that makes sense that we don't need SSA construction here. Okay, so we get to generate feed nodes by hand. That's neat. Okay. Oh wait, we can just straight code gen it. Oh wait, these are, I see. We're generating the individual expressions. So you code-gen the const, then we create the compare. And then, okay, then we create basic blocks. I'm getting ahead of myself. I think I should get through this first before reading on. So then value, so LVM value. I really should have namespaced this. Cond codegen. It's the pointer. Does LVM handle the optimization? Yes. I think, yeah, I did a little bit of this earlier today. So if we go here, I have, is it here? I guess this would be the easiest place to look. So this is the little snippet, the snippet, initialize module. This is the snippet that handles, I guess, just making the LVM context. And in here, we also initialize a bunch of, we initialize the function pass manager, and then we initialize a bunch of analysis managers. And then we link them together. And then we also add a couple of function passes here. And these are just built into LLVM that I'm using. So then further down here in run module passes, which I run on file input, this basically creates the module pass manager, which is run on which runs, I guess, like all the analyses and optimizations per module, which is, I guess, group of functions, and then it runs with the run function as self-explanatory. And then the other place I run optimizations is it's under AST, I think. Yeah. So during codegen for functions, after I create a function, if I'm using the JIT compiler, then I just run a function pass, or the function passes on it. So I guess LLVM handles the optimization, but I guess I'm calling LLVM here. And you can also write passes with LLVM. So we codegen this. If it doesn't exist, turn null pointer. Then we C is, so we create the create f cmp. What is the difference between all of these? Ah, we found Uno. Let's go. FCMP ONE. So presumably any is not equals. What is the O? Are we essentially translating our language to LLVMIR and letting it handle the rest? Yeah. Yeah, I guess that also explains why the tutorial is first language front end. Because you can kind of understand a compiler as a front end, a middle end, and a back end. And LLVM itself, the optimizer, is the middle end. And then the back end is just like codegen to assembly from there, which is pretty well defined. Sup, Taki? How are you doing? What am I looking for again? Assembly. Is this what I'm looking for? Where are the compare instructions? FCMP. Okay. Ordered. That's what it is. Okay, that makes sense. That was a quick read. I should keep this open, as I feel like I will need that very frequently in the future. Ordered not equals. You pass in. What do we pass in here? So left hand side, right hand side. Twine. What is a twine? We'll figure it out. So we need to pass in C, and then we need to p float 0.0. We need to get float. Do you mind the questions? Just asking them because I don't want to disturb your flow with them. Go ahead and ask them. I feel like they're really helpful in me also just getting a better understanding of what's going on. Where did I make a number before? I feel like I made one somewhere before. Number expr. Link to end. This is messy. Let's do that. Then what else do we need to pass here? cond. That makes sense. Okay, so then that makes sense. Okay, so we just compare to 0. That fair enough. Okay, so now we insert basic blocks. This is fun. Then function f equal, I can't use f function equals builder get insert block get parent. Yeah, okay. So then basic block true basic block create. Then you pass in context, you pass in then, and you pass in function. And here we change it to false. This one is end, I guess. Else, and then if cont. I guess cont here makes sense. Alright, so we've made the basic blocks. And we need to... Oh, okay. So we need to create the conditional branch. So this is C, we pass in TBB and then FBB. Oh, this should be a big C probably, right? Yeah, okay. What does ONE mean in the FCMP ONE? So in here there's like this is the LVM assembly language reference. And there's a bunch of different condition codes, and the one we care about here is ONE, which is ordered and not equal. So we're creating a compare that sets ordered not equal. So we built that. So we made that, and then what else do we need? Oh, right, that was about as far as I read up to. So this creates the basic blocks related to that. And then... So you get the function that the current basic block is within, and we create the blocks. I see, because it needs to be like flattened, so... Oh, we don't pass in the function for these two. Okay. Yeah, I guess that makes sense. We should save them then. So then we can emit the conditional branch since it exists. Creating new blocks does not implicitly affect the IR builder, so it is still inserting into the block that the condition went into. Also known as creating a branch to the then block and the else block, even though it isn't inserted yet. Forward references, okay. Sure. Fair enough. Okay, so then we change the insert point. We code-gen the then branch. And then this is the, so then this returns this to the merge block. Okay, that makes sense. So we set insert point to the true basic block. Yeah. So then value, so the true branch gets cond t branch codegen. Builder. Oh wait, then we need to check null pointer. So then we create the branch statement. Not merge BB. We have cont BB. This should be big C. Okay, that makes sense. And then I think we could just copy this over and then replace this with false blocks. I think. And then I'd need to insert the block. Now I just learned there's a thing as QNANs and SNANs from ordered. I can't lie, I'm not familiar with them. Feel free to explain them if you want. If not, I'll probably just look them up after during dinner or something. Oh, I need to move the insert point. Check the ordered definition in FCMP. Interesting. Okay, so this is not what I wanted to look up. Oh, quiet and signaling. Okay. Interesting. It's pretty neat. Wow. Yeah, good comms on looking that up. TBB equals builder get insert block. What does this do? This doesn't seem very intuitive to me. Wait, why is this? Why do I need this? Yeah, so we have this. Do they have docs in the headers? Usually there's a doc string somewhere up here at least. I mean, surely it'll explain here. First leetcode gen, the then expression. Create the unconditional branch. Oh, okay, that's something about a terminator here. That makes sense. Final line is quite subtle, but very important. The basic issue is that when we create the fee node, we need to set up the block value pairs to indicate how the fee will work. Oh, I see. So we're making sure that basic block is up to date. I see. Okay. Okay, that makes sense to me. That seems reasonable enough. So we need to re-update that. And then we need to presumably paste this here. Then, oh, we need to insert it again. So to insert FBB at the end of the function. That's what I'm missing. End. Does this not take this? Oh, wait, function insert. It's a little I. Okay. Let me set the insert point. We code gen it. If it doesn't exist, we null pointer. We create the branch statement, and then we update what it is. Okay. So then we make a fee node. Okay. So then we handle the continuation block. So presumably we insert it at end. And this is cont basic block. We set the insert point. And what else do we need? Okay, we need to create the fee node. Builder. Create fee. This is what type? Double? Yeah. Oh, we need to. Ugh. VM type get double from context. Yeah, not having water up here. Unlucky. So 2 and then if temp. Dereference that. Big, okay. Does the fee node decide which form is actually there at runtime? To my knowledge, fees are destroyed at some point when SSA form is also destroyed. So I guess fees don't really like exist in air quotes at runtime, I guess, to my knowledge. They're sort of just a construct in the IR to, I guess, make SSA form work. Okay, so then we add the incoming. So this takes T and then TBB. Oh, it's big B. Then we can finally return the fee node. Turn P. Oh, I guess that makes sense, yeah, because that's the value that we use from here forward. So we add the merge block, we change the insertion point, we create the fee node, add the block value pairs, and then it returns it. Okay, that makes sense. Okay, so now we have conditional code in theory. So then let's make this. We'll figure out 4 next time because I'm quite hungry, but let's make sure this works first. While we're at it, let's modify a test. Test if.in fee. Then def foo x if x, or if x less than 5, then what's the syntax again? It was here. Yeah. Then 1 else. Actually, we could just steal the Fibonacci. Whoops. So now we have both files by accident, so let's get rid of that. Fib x if x less than 3, then 1 else fib x minus 1 plus fib 2. Yeah, something about recursion. Wikipedia has a section on fee functions. That makes sense. That's probably a good read to have a better idea of what's happening. Let's see, does this test this anywhere? Yeah, we do need a semicolon. Okay, that makes sense. And let's print out fib of 5. It's a small enough number, so it doesn't take a year and a half in the JIT. Actually, we're not even running this in JIT. Build kaleidoscope, and then let's pass in the fib. Alright. Oh yeah, it does dead code elimination. Not dead code elimination. It just gets rid of the anonymous, it looks like. I guess that makes sense, but let's run it in interactive. Else fib of x minus 1 plus x minus 2. Okay, nice. Okay, neat. So that evaluates properly, it looks like. What else do I need to add here? Okay. I think that's actually all that we need to add for this. Let's just add everything. Add if statements. Implement. All right. Well, I've been going for like a little bit over 2 hours, so I'm gonna go get dinner now. If you're still here, thank you for tuning into the stream. Make sure you like and sub to my channel. And after I eat, I will schedule tomorrow's stream. It should also be at 5 p.m. PST. If you know anyone that can refer me anywhere, please send my resume their way. Make sure you connect with me on LinkedIn and follow me on GitHub, I guess. Yeah. Take care, all. Take it easy.